Hey guys, welcome to your second review video. Today we're going to be looking at our MLO of to solve linear one-variable equations by using properties of equality. Okay, looking at our MLO, this will always help us think about what are we going to be doing today. Today we're going to be solving equations. Alright, the rest is in there, right? It's going to be linear one-variable equations, right? We're going to be using properties of equality. But the main thing we're going to be looking at today is solving those equations. So let's look at steps to solve an equation. To solve an equation with variables on both sides. Your first step is to perform any distributive property shown in the equation. So really what this distributive property means is you're looking for those parentheses where you have to multiply something into the parentheses. Right, that's your distributive property. Your second step will be combine any like terms in the equation. When we're combining like terms, we do not cross the equal sign. Okay, so that's something to be very careful of. We're not going to cross the equal sign yet. We're only looking at each individual side of the equal sign. Step 3, move variable terms to the left side of the equation and constants to the right side. So we're always going to put our variables on the left and our constants on the right. And then our last step is to use inverse operations to isolate the variable. What we mean by inverse operations is, for example, in this example 1, it says plus 10. The inverse operation of adding 10 would be subtracting 10. Right? Remember, in math, everything has an opposite operation. So let's look at some examples following these steps. So, looking at example 1, 2x plus 10 equals negative 6. Alright, perform any distributive property shown. Again, we're looking for parentheses. This example 1 doesn't have any parentheses, so step 1 is done. Combine any like terms in the equation. Do not cross the equal sign. So I'm going to draw just a nice little line down my equal sign just to remind myself, okay, I'm only looking at the left side. Well, 2x and 10 are not like terms. Can't combine those. Right side, negative 6. That's the only term, can't combine that. So again, number 2 is actually doesn't have to do that either. Number 3, move variables to the left side and constants to the right side. So 2x is my variable, 10 and negative 6 are my constants. So I only have, all my variables are on the left side. Right now my only constant that's not on the right side is this plus 10. So again, doing that inverse operation, I'm going to subtract 10. So now I have 2x equals, well, negative 6 minus 10 is negative 16. My last step, use inverse operations to isolate the variable. Remember, anytime you have a number next to your variable, that coefficient is really being multiplied. This is 2 times x. The opposite of multiplication is division. So I'm going to divide by 2. 2 divided by 2 is just 1. I'm left with 1x equals negative 16 divided by 2 is negative 8. Always, especially for bigger numbers, use a calculator to help you out with some of that multiplication or division. Looking at example 2, 3x plus 20 equals x minus 8. Alright, so same step. Any distributive property, right? There's no parentheses, nothing to multiply through. Like I said, you won't always have that step. Number 2, combine any like terms in the equation. Yes, do not cross that equal sign. Well, 3x and 20, those aren't like terms. X minus 8, those aren't like terms. Then our next step, right, move variable terms to the left side, variable terms. Move constants to the right side, constant terms. Okay? So, 3x is on the left side, x is not. So I have to subtract x from both sides to get it from the right side to the left side. So 3x minus, technically this is 1x, right? That's 2x. Everything else just drops down, so 2x plus 20 equals, on this side I'll just be left with a negative 8. Then constants to the right side. My only constant on the right side is this plus 20, so I'm going to subtract 1. I have 2x equals negative 8 minus 20 is negative 28. Then our last step, getting that x by itself, isolating it. All right, I'm going to divide by 2. X equals negative 28 divided by 2 is negative 14. All right, same type of example as example 2 for example 3. I have negative 13 minus 7x equals negative 3x minus 33. Again, we don't have a step 1 here. There is no parentheses. Don't have a step 2 either, right? Negative 13 minus 7x on the left side, those aren't like terms. Negative 3x minus 33, those aren't like terms. So we're jumping into step 3, right? Variables on the left side, constants to the right. So here are my variables. So I need to move 3x over by doing the opposite. So that's negative 13. Well, negative 7x plus 3x. Right, negative 7 plus 3 is negative 4x. Those cancel out. I'm left with just negative 33. Then I have to move my constant to the right side. So I have to add 13 to both sides. So that's negative 4x equals negative 33 plus 13 is negative 20. And then again, your last step is to isolate the variable. So it has a negative 4. So then I divide by negative 4. Those cancel out. X equals negative 20 divided by negative 4 is positive 5. All right, we're going to look at just a few more examples on the next page. So go ahead and turn your note page. We have 3 more examples. Looking at example 4. Now, this one does have parentheses. It does have that distribution. So I need to take that 2 and distribute it to both the x and the 5. So 2 times x is 2x. 2 times 5 is 10. And that's still equal to that other side, negative 11. Then, we look for any like terms. 2x plus 10, not like terms. Negative 11 is the only term on that side. So again, it's not like terms. All right, so now looking for variables to one side, constants to the other. 2x is the only variable. R on the left side is good to go. 10 and negative 11 are my constants. So I'm going to subtract 10. That's 10 to get it to the correct side. So 2x equals negative 11 minus 10 is negative 21. And then again, our last step is to divide by 2. 2 cancel out. X equals negative 21 divided by 2 is really just negative 21 halves. We will leave pretty much everything in fraction form. We will really not use decimals in this class. So start getting used to leaving things as fractions. All right, example 5. This one has no parentheses, so it's not going to be distributing anything. But if you look, right, negative 13, only term on that side. On the other side, I have a 4x and a negative 6x. Those are like terms. I have to combine those first. 4x minus 6, or x, or 4 minus 6 is negative 2x. Then, right, variables have to be on the left side. So I'm going to add 2x to both sides. 2x and negative 13 aren't like terms, so I just keep it as 2x minus 13 equals 5. Looking for my constant, I need to add 13 to both sides. So 2x, right, these cancel out, equals 18. And then my last step is to divide by 2. X equals 9. All right, last problem. First step, this one does have parentheses, so I do need to distribute through. 4 times 2x, so 4 times 2 is 8x. 4 times negative 11 is negative 44. Minus 6x equals negative 3. Our next step, right, is to look to see if we have any any like terms on either side. So just look at the left, just look at the right. On the left, I have an 8x and a minus 6x. So 8 minus 6 is 2x minus 44 equals negative 3. Our next step, right, variables on the left. Well, there's one variable, that's my only variable, already on the left. Constants on the right, so add 44, add 44. I have 2x equals negative 3 plus 44 is 41. And then our last step is to divide by 2. This is another one that does not divide evenly. 41 is not an even number. So 41 half is my answer. All right. And that is all we have for solving one variable linear equation. You can go ahead and start working on the review activity 2.